We possess a more comprehensive map of the moon's surface than we do of the depths of our own planet's oceans. Look at this cross-section of the ocean. This bright slice right at the top, from the surface down to 200 meters, is the sunlight zone. Because solar energy reaches this depth, it sustains roughly 90% of all known marine life. This concentration of life attracts apex predators like the great white shark. Up here, animals rely on sight and an acute sense of smell to hunt in a sun-drenched environment. But a familiar, sunlit ecosystem is still a dangerous one. High winds, violent storms, and giant waves make the ocean's surface exceptionally hostile to human engineering. In 1912, the Titanic fell victim to these surface conditions. A disaster in these upper waters sent the ship plunging miles below, eventually claiming over 1,500 lives. The sunlit ocean we know and exploit is merely the roof of a much larger world. Beneath these waves, every layer becomes more mysterious and less explored than the last. Sinking below 200 meters, we enter the twilight zone. Here, temperatures drop sharply, and sunlight rapidly disappears into a murky blue. To survive the darkness, many animals synthesize their own light through a chemical process called bioluminescence. They use these internal flares to hunt, hide from enemies, or signal potential mates. The vastness of this open water supports massive anatomical growth. Creatures like the giant squid, which can grow longer than a bus, were dismissed by sailors as sea monsters for centuries until modern science proved they were real. Past 1,000 meters, we cross into the midnight zone. Mathematically, sunlight can no longer reach this depth. It is permanent, total darkness. Plant life cannot survive without the sun, making food rare. The creatures here survive on marine snow, a slow drizzle of dead organic matter sinking down from the layers above. Because a meal might only drift past once in a long while, you have to catch it when it does. Fish here have evolved unhinging jaws, oversized teeth, and glowing lures to trap prey in the dark. Without solar energy, the rules of survival mandate extreme efficiency. Life here is adapted to be highly specialized, capturing whatever scarce calories it can find. This chart shows the physics of the abyssal zone. The hydrostatic pressure here is equivalent to stacking hundreds of elephants directly on your body. It would crush standard human engineering in an instant. The environment is exceptionally bleak. The water is near freezing, the darkness is absolute, and there is very little native food to support complex life. Yet strange ecosystems exist. Clusters of deep-sea octopuses and sea spiders thrive around hydrothermal vents. These are fissures in the ocean floor that release superheated, mineral-rich water from the Earth's crust. The water erupting from these cracks can reach 400 degrees Celsius. At the surface, it would boil away instantly, but the immense water pressure down here physically prevents it from turning into steam. These vent communities prove that life doesn't strictly need the sun. By harvesting chemical energy from the Earth's heat, these organisms thrive in conditions that would be lethal to almost any other form of life. Finally, we enter the Hadal zone. As this scale model shows, if you placed Mount Everest into the bottom of the Mariana Trench, its peak would still be buried under 2 miles of water. At 11,000 meters down, the water pressure is over 1,000 times stronger than it is at sea level. In 1960, Jacques Piccard and Don Walsh became the first humans to survive this depth. They used a specialized submersible called the Trieste, designed with a massive, reinforced hull to withstand the descent. The engineering required for the mission meant the interior was extremely cramped. The crew was sealed inside a small steel sphere, risking an immediate implosion if even a single part of the vessel failed. That danger remains a reality today. In 2023, the Titan submarine lost contact during its descent to the Titanic. Experts confirmed it imploded under the massive weight of the water column, a reminder that the deep ocean does not forgive structural errors. And yet, our waste travels faster than our explorers. Scientists mapping the bottom of the Mariana Trench have already found plastic waste resting in the silt. We have explored less than 10% of the ocean floor. The Mariana Trench remains an alien frontier, a world where thousands of unknown creatures are likely still hiding in